So, Lightwave gurus in the house. Anthony, my friend, I see your comment yesterday about OpenVDB and Lightwave, and you want to create some fluids, and that's really simple in Lightwave with OpenVDB and the node editor. But it's all times the same. If you do some things in Lightwave that bring your computer under stress, then it would crash. So the reason for the most issues that the user have with OpenVDB and Lightwave is that he are too hot, on the mouse. So it's better to stay cool, So do you not scrub in the scene, then all would be fine. And the second is to understand what that node editor do. So I show today really a simple scene. So let us share the screen. It makes no sense that you see myself. It's better to see here the scene. So that's really a simple scene. That's the basic. And I show us first the simulation. And you see in that simulation a mesh that emit a volume. So I use 3D geometry, real geometry, as an emitter to create that fluid. And that's really a simple node setup, and I can show it here if I change here the view to the node editor. So what do you see here? In the moment you see that OpenVDB sequence is played from my hard drive. So I load it. It's only a test. It's a VDB file, a sequence. So I can then render it out. But if I want to create it, then I need before that little setup here. And I think for everybody is it clear that it's a scalar node. With that scalar node you scale the voxel size. And you can use that scalar node to put it in whatever you want, whatever voxel size, and can create the voxel size. So that's the size of the voxels in that grid you built. So then a second, I hope I can show it in one screen here. If I go here a little bit so in that way. So if I now put that out here, bring it offline, and you see here nothing is happened. But if I put my setup here in the grid, then it would become back. So we calculate it now. So now we have here that measured volume. So in what way works that? And that's really simple. So the simple idea is you have a emitter source, and you have something you can collide it with, have a collision, for that. So I need in the end two objects. They are relevant for the setup, and the first is that pool. Let us call it pool, that thing here, and that pool need a collision detection, and we have here an emitter, and that's here my mesh source. And you find that mesh source here in the on 0 in the scene if you later open it, but in the end it would be then build the mesh on that place your null object with your VDB evaluator is built. In the end, if I show it here, that's my object, that's call it null, and that call it null object have here the option OpenVDB evaluator, and you see it. If you do it in that place, it would generate in that place then the emitter. So let us go back here to the properties, and you see here the following. I used to put out particles, not the Lightwave particle system. I use the scatter node from OpenVDB. That's this one here. And this scatter node, with that node you can say, okay, what kind of scatter mode you will use. In my case it's a point density. And the scatter target is null. That means that null object is the place where the particles will be emitted. So that's the reason that you see that it's here emitted on the place the null is, but the original source for the geometry is under that. So if we change it here a little bit, and I can show it, you see that the original source is here. That's this one here. So I can show it quickly. It's low polygeometry. That's things, yeah. But that's not from interest. Born, all the particles will born in the place where the null is, yeah. So, and the null is here. One more time, you can see it here. And if we go in the scene, yeah. So there's a place. And now you can say, okay, I need a collision object. So you build it, yeah. And the original node, I rename it here, pool collision detection. The original node is mesh to volume, yeah. So if you load it in here OpenVDB, that's this here, mesh to volume, yeah. That's the node, the original node. It's only rename it here, yeah. So as next, you have to define the place you want to that the scatter node emit particles. Yeah, so I call that emitter, but in the end that's also a mesh to volume node, and the mesh to volume node have a target mesh. That's, I call it emitter, and the reason is in my scene it is the emitter. Yeah, so I call it emitter, and there you can say, okay, what type is it? Yeah, you have fog volume and level set. So, and we will build geometry, so the type is level set. Yeah, and that's all. All other you can ignore on the first for your test. And then you close it. So, and now you need that you can bring it to life. You need then here the solver. You need the solver for one reason. The solver have a collision grid. And that collision grid represent in the end then that pool. No? So it have to collide with that. Yeah? With that geometry. And what have to collide? Yeah, that's the particles from the scatter node. So we build that particle system, we build with the scatter node, we put it in here in the particle system in. Yeah. Use particles in that place here is for the Lightwave particle system. So we use the internal particle system from OpenVDB in that case. Yeah, for that case. So now we have here the solver, and then you can here say the solver, give him the pick and flip function and also gravity and so on. And in my case, the gravity is -15, and I have 100% a flip solver now and not a pick solver. If you make it to 10% or 0% or 50% or something like that, then you become more, yeah, a glue effect, you know? And so 100% mean it's the most possible fluid thing, yeah. So the subframe steps is for everybody clear. Use also bullet or something like that. So that's the internal subframe steps to calculate the that. And if your subframe steps are higher, then it calculate more correct. Yeah. So then you have your different integrators. In my case, I use Euler. You play with it, yeah. I use Euler. And then you have the surface, and that mean you can do it in that way here. You can study it and play a little bit with dilation and smoothing and so you can that way make the surface from your emitting particles, if you mesh it, yeah, to a mesh, make a little bit rounder, and you have thousands options what you can do there. The same as it with visualize. If you want to see it in the process, do it or leave it, yeah, show it or not, and that's the solver. And if you then put that solver directly in the grid here, from that solver from grid to OpenVDB grid, so that you calculate it, then you have it in original. So what I do here with that filter, that's a normal filter, is that you can play after that to clean up a little bit the particles, give him different filter types, and yeah, the most I think will use then Gaussian or something like that, but you have many filters, yeah, to make it more smooth, yeah. And you can also define with iterations and so on in what way it would be calculated. So we have it now, and now is it active, and the CPU can now calculate it. And the thing is now, if you want to calculate it, let us go to the camera view, that you not scrub now in the scene. If you do that, yeah, then the possibility that Lightwave crash is possible. And the reason is that your CPU then, if you jump in that frame, in the frames here, that you cannot calculate it fast enough, and yeah, then you kill your computer. Yeah. So that's a simple reason if you do things like that. That the first is that you, so as tip, yeah, that you say here, not here play exactly right, bring it off if you have to plan that you go here to play, yeah, make it off. So and if you want to see a preview without calculated and save it directly as image as OpenVDB sequence, yes, as OpenVDB data, then you can step, for example, with your keyboard here in the frames, yeah. So now you can see if you step frame by frame, the CPU have enough time to calculate it and can calculate it quickly, frame by frame. And to say it here clearly, that's a very old CPU. It's i7 4930K with 4.5 gigahertz. So today we have CPUs that's 3 times faster than that. So I think on a modern computer, on an actual computer, it would go very much faster as here. Yeah. So a second tip is, if you do that, I change the screen here to show it. I press on that, yeah, and so you have the next frame then to calculate. But what you also can do, that it make it much easier for you to have a preview, yeah, so that you not have to save it out as a final sequence only for testing, is to say, okay, make a preview, yeah, make a preview, and then you say, okay, make a preview, and now Lightwave do the following. It would be capture frame by frame what you have calculated before in that notes tree and show it to you. Yeah, and if you now have the time to wait, then let him calculate that, and Lightwave would, or I mean the CPU would calculate it so fast as possible. Yeah, and if you now, yeah, make a coffee or something like that, or buy a faster computer or something like that, and you would see in the end that preview. Yeah? And if you have calculated, then it also is stored. Yeah? So, and if that what you then see there, is that what you want, I cancel it here, yeah? It's only for showing in what way you can work without that Lightwave crash, yeah, or make stress with you. Then you can say, okay, give me the node here under properties, yeah, and bring it offline. That's important. Bring it offline. So as you see nothing here with your setup. Now you can say, okay, save it. For example, here a sequence. Then here you have your folder grid cage or something like that, and then say your test, yeah, and say you need it as sequence, and say save. And now would be happen the following: Lightwave begin now to saving that OpenVDB sequence, yeah. You cannot see it in the moment. I think you can now see it. So, and now he calculates a complete sequence, yeah. So now you can do other things, yeah. So Lightwave would now, and then you see it here also in the frames area, give you and build OpenVDB sequence step by step, yeah. So, and if it's ready, I make no upload. It's only for showing in what way it works. You have in the end in your grid cage folder your tests, VDB sequences, and if I load it here with that OpenVDB info node and put it directly in the grid, then you can see it here, yeah? And now you can work with it. Now you can scrub and step in it, and it would not crash, yeah? So, and now you see that you have some fail calculations in there, yeah? Things like that artifacts, yeah? Let us go a little bit wider. And now you have the possibility with a filter to clean it up. Yeah, for that is that filter. You must not use that filter here. For the preview, you can use it then if your OpenVDB info node have stored and loaded that VDB file. Then you put it in there, and then you see directly the change here. Yeah, and that's a Gaussian node, for example. Yeah, or you take mean curvature flow or something like that. Whatever you want, Laplacian flow. Yeah, that's also good. Yeah, that make it not too clean. Yeah, or you would it have very clean, then you use a Gaussian node. So, and that's all, then you have it. And if you then have it, yeah, then you can render it. Yeah. You load it then. So that's the octane scene, yeah. So now you have your final, and you can see it. Yeah. So and that's a little bit the way to work with that. And I mean, this kind of that setup is really easy. So there's nothing complex to understand. Yeah. So you have your scalar node to scale the voxel size. You have here your collision object, that's the pool. You have your emitter, that's your emitting geometry. You have here the scatter node, that the internal particle system from OpenVDB know what you want. Yeah. So for example, I have here a spread from 100. Yeah, and the density, you play with that. It's all really funny to see what's changing if you play with that. And also with the scatter mode, you have 3 scatter modes, yeah, points total. So you can say, if I say it's here points total, you can say, okay, point count is 2000, not more. That's also funny, yeah. That make from time to time the calculation a little bit faster. So for me, is it now point density, but that is it, yeah. So and in that way you can play with that, and in that way you use not the particle system from Lightwave, you use the internal particle system from OpenVDB. So I think I talk too much. I hate it. So the best way is I package now the scene without the OpenVDB sequence file, so that's some gigabytes, yeah. So you have the same to calculate it in the end, but that's the principle to work with it, yeah. So that's really, really easy. If you know that you work in a way with OpenVDB that your computer make no crashes, yeah, and that was the way I show now. So I package the scene, I link it in Facebook on Anthony's channel, yeah, Lightwave Salvation, and also on the Lightwave digital channel, and then you can play with it. That's really one from the simple setup you can do to test the functions. And the best thing is, first, read the fucking manual, and second is play with that. Playing means learning, yeah. So if you know, if you think if you build your first scene that then all would work directly, no, you have to learn it and to study it. And if you do it often, after time, in my case it was 2 weeks or so, then you understand completely what's happened there. And then you can imagine what will happen if I do that or that with it OpenVDB nodes, if I combine there to that level set, yeah. So and that's a little bit the thing. So OpenVDB is not in that way implemented, if it's implemented in Houdini, yeah. But we have the most functions in Lightwave embedded, and that here you have seen it, it's Lightwave 2019.1.5. That's not Lightwave 2023. So it works for many years now, and I use it for many years now for many things, and it works. And if you know in what way you have to handle it, then it brings you really fun, and it's not complicated. Yeah. So, okay. See you later. Bye.